Welcome back everyone, thanks for checking out another video. In this episode, we get the engine back in. It is fully dressed, it has the turbo on. We have a whole bunch of K-tune parts installed, we have the wiring harness installed. It's basically all plumbed. I'm super happy with the progress that we're making, but I feel this video might be a long one, so why don't we just jump right into it. Okay, so in order to install our low profile valve cover, we do need to modify the spark plug tubes. As I mentioned in the last video, we are running shorter coils. They are Honda J series or V6 ignition coils. They are physically shorter than the K series coils to allow us to get that extra little bit of clearance that we need in the engine bay. And because they're shorter, we have to cut down the spark plug tubes. These spark plug tubes are much taller to accommodate the original K series ignition coils, but we don't need them to be this tall. They stick out past our valve cover, so we got to cut them down like I've done on these two. So I'm going to show you how we cut down these spark plug tubes. It's very easy, it's not messy. Let me get this valve cover off and I'll show you what I mean. All right, with the valve cover off, we have to cut down these spark plug tubes. Like I said, I've already cut down these two. We cut down the spark plug tubes approximately 15 millimeters, and we cut these down with a close quarters tube cutter. This is a standard rigid model number 104. You can buy this at Home Depot. They are pretty inexpensive. I did modify mine slightly. I've ground off a little bit of this adjustment knob so it clears the cam caps in the engine. Technically, if this was an engine that was all apart and the cam caps weren't installed, you could use one of these without having to grind off a little bit of it. Or you could actually just remove 2 cam caps at a time on the spark plug tube that you're trying to cut to get the clearance you need. But I found if you grind off a little bit of this tool, you can swing it around in the space without it making any contact with anything inside. You do have to make sure you position the cam lobes in the right spots so that they're not going to be in the way when this spins around. So it does take a little bit of alignment and playing around with, but it is fairly straightforward. It's not messy. It doesn't leave any shavings in the engine. You just basically tube cut off the top of these, and then we have the clearance we need for our valve cover. So I'm gonna mark out these last 2 tubes and I'm gonna cut them down with the modified tube cutter. All right, so I've just marked out with a Sharpie about 15 millimeters down from the top. I'm gonna take care of this guy first. I'm gonna rotate the engine a little bit to get the cam lobes out of the way so that the tube cutter can swing without them being in the way. But then I will put the tube cutter on this spark plug tube and we will cut it off. Okay, and just like that, we have shortened the spark plug tube to the length that we need for our low profile valve cover. So I'm gonna take care of this last one. I'm not gonna bore you with it in the video because we have a lot of content to cover. Let me take care of that and then we'll continue on. All right, before we bolt the valve cover down, I do want to talk about the slight changes of how this valve cover bolts down compared to a stock one. Because this is a low profile valve cover, the stock original bolts that bolt the valve cover down don't work anymore. I have a stock one here on the left and one of our brand new ones that we've created on the right. We provide brand new hardware to mount our valve cover. We provide 6 new bolts specifically designed for this valve cover because it is super low profile. They are significantly shorter than the original ones. We also changed the positioning of where the bolts fasten the valve cover down. It is more symmetrical now. The original Honda valve cover kind of has weird staggered offsets. We've made it basically symmetrical. We also provide brand new grommets and nuts along with OEM seals to seal the spark plug tubes that we install. So the valve cover has all the stuff that you need except for a valve cover gasket. You can reuse your original one or you can buy a brand new one. In regards to installing these bolts, it is a pretty straightforward procedure. Basically just remove one at a time, replace it with the new one that we provide, and just match the positioning of how the valve cover is all laid out. The one thing to note is this bolt right here is a weird one. It is long and it gets in the way. You could technically buy a brand new one of these and just replace this one, but the easiest thing to do is just take it out, cut it off, put it back in, save yourself some money, because cutting it off works perfectly. That's what I've been doing on mine. No need to waste money buying a brand new one. So yeah, just needed to make sure I covered all that for you guys before we get too far ahead of ourselves. So let's continue on and get this valve cover bolted down. All right, valve cover back on. One thing to note about installing this new valve cover is we install brand new OEM Honda spark plug tube seals that seal around these spark plug tubes. When they're brand new, they're very tight, so sometimes you have to use a little screwdriver to make sure you push them down so they don't get caught between the valve cover and the spark plug tube. So just pay attention to that just so you don't damage the brand new spark plug tube seals. Now that we have the valve cover on, we might as well take care of some of the basic stuff. We need to install a set of spark plugs. If you're going turbo, I recommend running these spark plugs. They are 1 heat range colder for this specific engine. These K24 Z engines use a different spark plug than the older style K20s and K24s. So you're gonna wanna run this part number. They usually come gapped to 21 thou. I would double check to make sure the gap is good before putting them in, but and if they're not, just set them to 21 thou. That's what I usually run. Also, as mentioned, we're changing out the ignition coils for J series V6 ignition coils. So I've ordered up a set of brand new OEM Denso ignition coils. I usually get all of this stuff from Rock Auto. They have great deals. So this is the part number, the Denso part number that you want to order for the ignition coils. I already have this part number listed on my website, but here it is again, just in case you need it. Additionally, you're gonna wanna pick up an RSX Type S intake manifold gasket, 2002 to 2006 RSX Type S intake manifold gasket. You're also gonna need an exhaust manifold gasket. This is a 2012 to 2015 Honda Civic SI exhaust manifold gasket. Make sure to get the multi-layer metal one, not the cheap ones that look like foil on the outside with like crumbly stuff in the middle. Those ones fail instantly. Also, you're gonna need a new serpentine belt. The engine with this combination of accessories never actually existed in an OEM configuration. The K24Z engines never had a power steering pump. They just had a bolt-on idler in its place. So all you gotta do is unbolt that idler and you can bolt on a RSX power steering pump or a TSX power steering pump. As long as it has the PND part number on it, you should be good. This one here, I believe, was off of a TSX. You can probably use a CRV one, an Accord one, an RSX one, a TSX one. From what I've seen, they're all basically the same, but I might be wrong, and you guys can let me know in the comments if I am, but for sure RSX or TSX is gonna work. So because we're adding a power steering pump on this engine, no off-the-shelf serpentine belt is gonna be long enough. So we now need a longer serpentine belt because of it. I started off with the TSX belt because the TSX is the closest configuration. However, the K24Z engine actually has a slightly larger crankshaft pulley, slightly larger than the TSX. So therefore we have to run a longer belt than the TSX. The TSX uses a 69-inch belt, and what I found is a 70-inch belt works perfectly on this engine. I'll put the part number up on the screen and in the video description, but the Dayco part number is 5070700, and that's a 70-inch belt that works on this combination of accessories. So I think we're gonna start there. I'm gonna start installing the spark plugs, the ignition coils. I'll put the serpentine belt on, and we'll just continue on. All right, with all the maintenance stuff out of the way, it's time to start taking care of the K-Series to Porsche specific connections, such as connecting the cooling system, the fuel system, the power steering system, the AC lines. Also, we have to take care of plumbing the turbo, the oil feed, and the coolant lines, and the catch can. There's a whole bunch of stuff we gotta take care of. Pretty much for all of those connections, we're gonna be using K-Tuned components. K-Tuned is the OG of K-Series swaps. They have an extensive catalog of parts that will make your life a lot easier, whether you're doing a K-swap into something traditional like a Civic or an Integra, or you're doing a K-swap into a 911 like I am. K-Tune's collection of parts will make your life a lot easier. I used K-Tune parts on my original 997 build, and I'm happy to say they're helping me out again on this 996 build. On this build, I'm gonna do my best to document which K-Tune parts we use on these 911 K-swap builds so that I can create a sort of a master list of the parts that you're gonna need to do your build. Additionally, let me know what you guys think, but I can create a package of all these parts with K-Tune so you can kind of just click one spot and get all the parts that you need for your 911 build. So I'm gonna try to do a high-level overview of the parts that we're gonna be using to dress this engine, to make the connections to the cooling system, the fuel system, and all the other systems that we need to connect to make this K-swap work in the 911. And I will go into more detail as we progress, but we're gonna be using K-Tune parts for the fuel system, such as their billet fuel rail, their fuel pressure regulator, their fuel injection adapter fittings that will allow us to connect to the original Porsche fuel lines. We're also gonna be using their PTFE collection. They have a full catalog of PTFE lines and PTFE fittings that are E85 compatible. So we can basically take care of our full fuel system with K-Tune components. In my opinion, that's the easy part of things. The more complicated thing we have to take care of is the cooling system connections. These Porsche 911s have a great cooling system, a ton of capacity, but we have to make sure we connect to it properly so that we aren't overcooling the engine and not overheating the engine by connecting to it incorrectly. To help connect the original Porsche cooling system to this K-Series engine, we're going to be using a bunch of K-Tune components, as well as my upper coolant housing adapter. I've talked a lot about this part. It is available on my website now. But what I want to talk about here is the three main parts that are available from K-Tune that will help ensure that this engine maintains proper operating temperature. The three parts are this upper coolant adapter, the swivel thermostat housing, and back here, this little adapter that helps us get rid of this hard line that would normally connect to a heater hose, but in this configuration just won't work in the Porsche K-swap. So these three main parts kind of all work together and will help ensure the engine runs at proper operating temperature. So the way the K-Series engine maintains its operating temperature is obviously with the thermostat. This is the K-Tune swivel thermostat housing. This is their new version that uses an OEM style Honda thermostat inside. The OEM Honda thermostat is a dual stage thermostat. The reason that that is important is that the K-Series engine is always kind of bypassing coolant, and it bypasses it to the back of the thermostat housing, which is back here. This adapter allows hot coolant to circulate back to the back of the coolant housing and regulate the opening of the thermostat, allowing cool coolant in from this rad connection right here. One thing I want to say is there are a ton of knockoffs out there. There's a bunch of knockoffs for the K-Tune thermostat housing. There's a bunch of knockoffs for this bypass housing. The issue with the knockoffs is they might look the same, but they don't really work the same. I see a lot of knockoffs of this part here, and the issue is they don't seem to be machined properly inside, and they cause a flow restriction. It is super important that there's no flow restriction through this housing to the back of the thermostat housing, because if not enough hot coolant makes its way to the back of the thermostat housing, then the thermostat won't open, and then you will have overheating issues. There's also a ton of knockoffs of the old version of this thermostat housing, which just doesn't work properly on K-Series. You really do need to use an OEM style Honda dual stage thermostat. And as far as I know, the only one on the market is this K-tuned thermostat housing. Additionally, this thermostat housing provides an extra port, which allows us to connect to the Porsche expansion tank, which I'll go into more details, but this port here is extremely important as well. One thing I should make note of is the K-Series thermostat housing is kind of two pieces. You do reuse the original back half, and there's one other connection back here, which is this one that I have this fitting attached to. This is the return inlet for the heater hose. K-Tune makes this special adapter to connect to it because it's not a standard connection. Normally you have this hard line that's attached there, but this hard line simply won't work in this application. So what we're using is the K-Tuned adapter and then a -12 fitting, and we're gonna connect it to the heater hoses. But once that's all connected, it'll all make a lot more sense. All right, well, I think it's time to start assembling this engine, and as we get further along, I will try to go into more detail about the specific connections to help make this all work. All right, time to install the turbo on this engine. Beyond just bolting the turbo up to the turbo manifold, we have to take care of all the connections such as the oil feed, the oil drain, and because this is a ball bearing turbo, we have to take care of the water cooling connections. For the oil feed and the drain, we're gonna be using K-Tune parts. K-Tune makes a really nice oil pressure adapter. The K-Series engines have an oil pressure switch on the exhaust side of the engine. It's right here. This is not needed anymore, so we're gonna remove that oil pressure switch, and in its place, we're gonna be installing their oil pressure adapter, which is a nice stainless steel piece that allows us to tee off that oil pressure source so that we can feed the turbo its oil that it needs, and also teeing it off so I can feed my oil pressure sensor. The Link ECU is gonna be using to monitor oil pressure for things like the oil pressure reading on the dash, as well as oil pressure protection in case of oil pressure loss for some reason. This fitting from K-Tune is a super nice piece because it does have the proper threads to thread into the block because it's not a standard NPT thread. Additionally, it's all stainless steel, so it's nice and strong. I know a lot of guys will use brass fittings and thread it in there, but what I've seen is the brass fittings break. I always use this K-tuned oil pressure adapter. It's super nice, it works really well, and I never have to worry about it. Additionally, I'm gonna be using K-Tune's Dash 10 AN fittings and their braided hose for the drain, but that'll be one of the last things I do because I still have to remove the oil pan and add a drain fitting into the oil pan. But the plan is to remove the oil pan once the engine is back in there because right now it's sitting on the oil pan. So I'll be taking care of that at a later date, but for today, we're gonna be installing the turbo, we're gonna be taking care of the oil feed line, as well as the coolant connections for this turbo. I get asked all the time on how to connect the water lines to a turbo. The way I like to do it is with banjo fittings. On my original build, I used some very expensive banjo fittings, but this time around, I've opted for these less expensive Amazon fittings, and we'll see how they work. The banjo fittings are just easier to work with. It's a tight space, and using AN fittings in there, it's difficult to do them up. These Pulsar turbos come with AN fittings, they're Dash 6 AN fittings, and I could use AN fittings here, but my preference is just banjo fittings because it makes my life easier. So I'm gonna get to installing this. Once it's all installed, I'll show you how I've taken care of the oil feed and the coolant connections. All right, so the turbo has been installed and I've connected the oil feed and the coolant lines. For the oil feed system, I've installed the K-tuned oil pressure sensor adapter, which acts as like a T, and I have one of the outlets connected to the K-tuned Dash 4 PTFE line that I custom made up. I used one straight fitting and one 90 fitting to feed the oil supply for this turbo. I've also connected the coolant lines for the turbo. There are a bunch of different ways to connect coolant lines on turbos. On my 997 build, what I actually did was I utilized this port right here. You can take out this plug and install, I believe it is the S2000 fitting, which is this guy right here that you can use as the water outlet. And then on the other side of the turbo, you can feed it back into the heater hose. This time around, I've opted to do something different. This time what I've done is I did drill and tap into this coolant housing adapter and the return to the heater hose like I normally would do. I could have just as easily teed into this heater hose and run it from there, but it was pretty easy to drill and tap this coolant housing and put a fitting in there and made for a nice clean install. For the return, I did tap into the heater hose return. I've also connected the steam port. The steam port is right here. It is a 1/8 NPT to 3/8 hose barb. So this is 3/8 hose that we're gonna be running over to the expansion tank, the Porsche expansion tank, which is up here in the engine bay. So we're gonna be running it to this fitting here. This is actually 1/2 inch, this fitting here. So right close to this point, we're gonna be switching that 3/8 hose to 1/2 inch with an adapter. Right now, I've just left a lot of extra hose, kind of like how I've done with the heater hoses, but there's just a whole bunch of extra hose. So when the engine is in the engine bay, I can just use that extra hose, figure out where I need to cut it, and then cut it and connect it to the expansion tank up there. The plan is to do the same thing with the 3 1/4 inch heater hoses. They are extra long at the moment, but when the engine is in the engine bay, I will figure out the final length that they need to be, then cut them at that point, and then connect them to the car right about there. So I think that's it for all these coolant connections. The next thing I have to take care of is the intake manifold. I'll get the intake manifold installed. I'll install the injectors. I'll install the K2 fuel rail, the catch can that we're gonna be running. And then I think the last step will be install the wire harness. And then we'll be able to put this engine back in the engine bay. So I'm gonna take care of all that and then I'll show you how it turns out. All right, before we actually install the intake manifold, I should just go through what our intake manifold is again. I have a whole video series on this intake manifold, but we've changed it slightly since then. Our intake manifold solution is kind of a 2-piece thing. It uses a Skunk 2 Ultra Street intake manifold. You basically have to buy a Skunk 2 intake manifold and you just use the lower portion of it. You don't need to use their plenum version. We supply the intake plenum and spacer. It used to be a 2-piece arrangement, a separate plenum and spacer, but we found that that was too complicated, required some long bolts that were a pain to install. So what we've done is welded the 2 pieces together, which simplifies things a lot. This combination of intake manifold allows you to use the Porsche 74mm throttle body, and it positions it in a spot where it clears the Honda power steering pump. As far as I know, this is still the only intake solution on the market that positions the throttle body in this direction and clears the Honda power steering pump. Eventually, we do want to create whole intake manifold solutions, so you don't have to buy the Skunk 2 portion, but that is a ways off. For now, this is what we have. It works really well and it fits in the engine bay really nicely. So this intake manifold, you basically just bolt up what we supply to the Skunk 2 intake manifold. On our portion of this plenum/spacer combination, we provide 2 drilled and threaded holes. One for the intake air temperature sensor. This is a GM off-the-shelf intake air temperature sensor. We provide our base map scaled for this intake air temperature sensor, but technically you can use other ones, not a big deal. We also supply it with this fitting, which is a 1/2 inch port for vacuum. This is where your vacuum supply will come from, so you can feed that to a vacuum manifold. From the vacuum manifold, you'll be able to connect things like your blow-off valve, your fuel pressure regulator reference, the wastegate reference, your map sensor, your brake booster vacuum source, all basically from this one fitting. So all that being said, the intake is ready to bolt on, so why don't we install it? All right, I've made some great progress of assembling or dressing this engine. The intake manifold is now on. I've installed the K-tuned billet throttle body. I've temporarily installed some of their fittings. This is the Dash 8 feed line. I think a 90 is gonna work on this side. And then this is the Dash 6 return. Not sure how I'm gonna route this one just yet. It might be a 45 down because the fuel pressure regulator is probably gonna be positioned in front of the engine, just in front of the engine brace on the little shelf that's in the front of the engine bay. I've also installed the 1000cc injectors. The wiring harness is all installed, and I've done a whole bunch of wire management to kind of hold things in place. I've also installed the catch can. I still have to take care of the catch can's drain. That will have to wait until the engine is back in the engine bay so I can remove the oil pan and drill, tap, and or weld in the fittings that we need for the catch can, for the turbo drain, and also for the dipstick, which I will get to eventually. We have to add a fitting into the oil pan so that we can add a dipstick. That's one of the last things I'll be taking care of, but I will show you how we take care of the dipstick for this engine. I haven't installed the throttle body yet. It is actually much easier to put the engine in the engine bay for clearance reasons and to prevent any potential damage to it. So I think we're actually at a point now that we can get the engine back in the engine bay and just continue working away at finishing this off so that we can get this engine up and running as soon as possible. All right, engine is back in the 996, and I am so happy with how this is turning out. It makes such a big difference having the powder-coated valve cover on there and the powder-coated engine brace, and then the fact that it's all fully dressed. It looks so good in this space. It fits so well. It's tight, it's a tight engine bay. There's not a lot of room up top, but there is just enough to make it work. Everything is looking really good in here. The wire harness is all installed. I even connected it to the bulkhead connectors there. These wires are kind of extras. One is the map sensor that will be connected to the vacuum manifold that I will probably be mounting somewhere around here. These 3 additional connectors are for boost control, oil pressure, and fuel pressure. They're technically optional, but I will be adding them to this setup as well. Why don't I lift up the car and show you everything from underneath? All right, with the car up in the air, I can show you what it's like underneath. I am so happy with how the packaging has turned out under here. Everything has its place. It fits all nicely. There's just enough clearance for everything. The one thing, wasn't sure about this one heater hose, if I should put the 90 in it or not. And there's technically enough space for it to run without the 90, but I think adding the 90 up here will make it much nicer because this hose technically has to come straight down along this line. And then underneath the drive shaft here, there are the original brackets that hold the heater hoses in place right there, and then they connect back there. So adding the 90 right there will allow us to have a much better angle, I think, to hit the heater hoses back there. But that should be a fairly easy thing to do, even with the engine in place. The one thing I forgot to do was remove all the extra sound deadening. All of it has come unstuck, so I might as well just pull it out. It's gonna be super messy pulling it all out with the engine in place. But also now with the engine in place, you can kind of see what I had planned for the rad hoses. This is the inlet for the cool coolant returning to the engine, and it will connect to this, which is almost a straight shot. Just has to kind of go around the catch can here. The other side's a little bit tighter, but we can still make it work. I'll show you what it's like on the other side. So on the driver's side, it is a little bit tighter, but you can see there is the outlet for the hot coolant coming out of the engine. The plan is to use a 90 there, and then a 90 back here to connect to the original Porsche hardline. And what I have here are basically some universal 1¼ inch hose, 1½ inch hose, and then transition adapters. So I will be able to kind of cut it in half, and then put those together with the transition. And I should be able to make that connection fairly easily. It's a tight spot to work in, but once it's all in there, I might take the turbo off just to make my life a little bit easier. But technically, I think I can do it all with everything in place. But it would be easier without the turbo on, so maybe I'll take the turbo off. Not sure yet. One other thing is I could probably make these guys a little bit shorter. They're just attached with banjo bolts and clamps, so I could just pull those off and shorten these hoses a little bit just to tuck them up a bit. But so far I'm super happy. This is the steam port hose that I have to shorten. I do have to just connect it to the fitting that's up there. So minimal things left to change. So pretty good progress. I'm glad the engine's back in. This has taken probably 4 or 5 times longer than it should have. I am struggling at capturing this. I'm not cut out for this. It has taken so much longer than it should have to do all this work and capture it at the same time, trying to make it as interesting as possible. But now that I've captured everything as best I can, I have to edit it all and we'll see how that all turns out. But I think again, this is gonna be kind of a long video. Because the engine's in, I think this makes for a good spot to end this video. Let me know what you guys think so far. If you like the video, do me a favor, hit that like button. If you haven't already, consider subscribing, and I will see you guys in the next video. Thanks again for watching, and I'll see you again soon. Bye now.